Keeping the planet clean and green means reducing the environmental footprint of fossil fuels. That means taking a new look at the role of commercial trucks, the workhorses of the global economy. The large amount of diesel engines being used in the world results in high nitrous oxides and carbon dioxide emissions, the drivers for the growing stringency of global emissions regulations. Ongoing diesel engine improvements continue to trade off between trying to decrease smog-forming NOx by using fuel to heat aftertreatment systems and trying to reduce CO2 by reducing fuel consumption. Tula is at the forefront of a worldwide solution by putting you on the road to a new and innovative technology to reduce NOx and CO2 at the same time. Tula is proud to introduce dynamic skip fire for diesel engines, the ultimate evolution of cylinder deactivation technology. dDSF optimizes each combustion event by choosing the right cylinders to fire at the right time to meet the torque demand. When dDSF commands a cylinder to skip, the intake and exhaust valves are deactivated and fuel injection is cut, completely cutting airflow through that cylinder. To reactivate this cylinder, the valves are open and airflow resumes. dDSF also transitions seamlessly to changes in torque demand by smoothly ramping the density of cylinder firings. Compared to conventional cylinder deactivation or variable valve trains, dDSF operates at the optimal efficiency for a wider range of loads and further reduces operating fuel consumption, all while maintaining optimum drivability and NVH. Diesel aftertreatment systems rely on high exhaust temperatures to maintain the ability to convert NOx emissions. This becomes a challenge while operating on all cylinders at low engine loads, where the exhaust temperature drops and reduces NOx conversion efficiency. But with dDSF, the exhaust temperatures are greatly increased due to increased cylinder loading and reduced airflow. The result is a more efficient conversion of emissions in the catalyst and dramatically reduced NOx at the same aftertreatment system cost. In fact, no other diesel technology offers this level of simultaneous fuel savings and reduced NOx emissions.
Tula, together with Cummins, developed and integrated dDSF controls to help illustrate how this innovative technology lives up to its potential in the real world. Our demonstration vehicle is a Class 8 line-haul truck with a Cummins X15 engine. And for the next few minutes, you'll get the chance to ride in a virtual test drive that will show you how dDSF looks, feels, and performs on the road. During the drive, we will show you how dDSF adjusts to different driving scenarios and provide insight into details such as NVH and emission control. During engine idle, it is a challenge to maintain after-treatment temperatures in a modern diesel engine. But dDSF enables high exhaust temperatures and improved fuel efficiency. At idle speed, dDSF shows a 20% reduction in fuel consumption while increasing exhaust temperatures by 40 degrees Celsius to maintain high after-treatment system efficiency, all while making sure NVH levels are not a factor to the operators. As we get on the road and begin to accelerate, notice how quickly dDSF responds to the increased demand for torque. When high torque is needed, dDSF activates all cylinders immediately. At low to moderate engine loads, dDSF responds instantaneously to changes in torque demand by dynamically varying the firing density, working in sync with fuel injection controls and air handling mechanisms such as exhaust gas recirculation, turbo boosting, or throttling. This allows the engine to operate at optimal efficiency while maintaining high exhaust temperatures throughout. dDSF operates at firing sequences striving for low NVH and seamlessly transitions between different firing densities. dDSF is also easier on the engine when compared to standard CDA. firing sequences are adjusted to utilize all cylinders evenly, reducing uneven wear over an engine's lifetime for improved durability. And depending upon specific applications, dDSF's added flexibility in firing densities, EGR rates, and fueling strategies are calibrated to balance desired improvements in fuel consumption, exhaust temperature, and reductions in NOx and CO2. dDSF also features deceleration cylinder cutoff, DCCO, which deactivates all cylinders during deceleration.
DCCO keeps the aftertreatment system warm and effective by greatly reducing airflow. In contrast, conventional deceleration fuel cutoff technology can render the system ineffective through unnecessary cooling, requiring more fuel to be effective again.
And dDSF works along with other deceleration technologies already in place, like engine braking.
Based on rigorous tests, the advantages of dDSF are evident. On the HD FTP cycle, dDSF reduces NOx by 23% and CO2 by 0.8% compared to all-cylinder operation. On the LLC, dDSF technology reduces tailpipe NOx emissions by 74% while reducing CO2 by 5%. With its simultaneous ability to reduce emissions and manage NVH, dDSF proves itself as a practical, cost-effective engineering solution, from heavy-duty or light-duty transportation to off-road or marine diesel to power generation or anything in between. Whatever comes next, let Tula help you get there.